Okay, so today we're going to take a look at using meters to model the decomposition of one whole into hundredths. And we're going to represent and count hundredths this time. So we're moving from tenths to hundredths. Now again, we're going to use the meter as our guide. So taking a look at number 1, we can see a tape diagram here representing 1 meter. And we can see that it's been divided up into 10 sections, and one of those sections has been shaded in. Okay. So we take a look over here and it says, what is the length of the shaded part of the meter stick in centimeters? Now, from our work with metric system earlier, we remember that the prefix cent means 100. So in this case, if we have 10 sections, each section then represents 10 centimeters. Okay, because remember that your 1 meter equals 100 centimeters. So taking 100, dividing it up into 10 sections, gets us 10 centimeters. Now, moving down to the next question, what fraction of a meter is 1 centimeter? Well, again, that then becomes 1/100th of a meter. Okay, so if there's 100 centimeters in a meter, each centimeter is 1/100th of a meter, because we've taken that whole of 1 meter and divided it up into 100 sections. So now moving on to part C, you can see that our shaded section now has been divided up into 10 smaller sections, each of those sections representing 1 centimeter. Okay, so we've gone from 10 centimeters up here, and now we've modeled out each of those centimeters. So in fraction form, express the length of the shaded portion of the meter stick. So now again, our denominator is going to be 100ths. Now coming back over here to our meter stick here, you can see that we have 10 sections shaded in. So our shaded portion here now represents 10 hundredths of a meter. Okay, because we have 10 centimeters, so we have 10 hundredths of a meter. So now in decimal form, express the length of the shaded portion of the meter stick. So taking our fraction up here, converting it into a decimal, is going to look like this. Now again, be very careful with what numbers you put where. So now we have 10 hundredths of a meter. Okay. So now what fraction of a meter is 10 centimeters? So now again, looking back up here, our 10 centimeters is 10 hundredths of a meter. Now using what we know about equivalent fractions, we can then divide our numerator and our denominator by 10, and we get 1/10 of a meter. So going back up to letter D, we can see that our 10 hundredths is also equal to 1/10. Okay. So that extra 0 after the 1/10 doesn't change the value. So now moving on to question 2. If we're going to fill in the blanks, 1/10 equals how many hundredths? So going back up to look at what we did over here in E, we can see that 1/10 equals 10 hundredths. And again, connecting it to what we know about fractions, multiplying by 10 tenths gets us over here to our 10 hundredths. So now looking at part B, now we have the same question, but this time in fraction form. So your 1/10 of a meter becomes 10 hundredths of a meter. And then finally step C, if we have 2/10 of a meter, well now we have 20 hundredths. Okay, again, thinking about multiplying your numerator times 10, and then multiplying your denominator times 10. Okay. All right, now moving on to question 3. We're going to use the model to add the shaded parts as shown. And we're going to write a numbers bond with the total written in decimal form and the parts written as fractions. And the first one has been done for you. So let's take a look at what this looks like. So we have our full meter. Okay. Okay, and we can see that we have one square shaded in. So this is our 1/10 right here. Looking at our next tenth, we can see that this has now been divided up into hundredths. And we can see that we have 3/100ths shaded in. So looking at what it looks like in fraction, you have your 1/10, okay, which is this section right here. We have our 3/100ths, which is those three smaller pieces right there. Okay. Now, because 1/10 equals 10/100ths, what we're doing is adding 10/100ths plus 3/100ths to get our 13/100ths. And then written as decimal form looks like that. Okay. And then as our number bond, we have 13/100ths up there, being broken up into 1/10 and 3/100ths. Okay. So now let's do a couple on our own. So again, taking a look over here, we have our 1 meter. Now this time we look and we see that we have 2 full squares shaded in. So in this case we have 2/10 of a meter plus. Now looking at our hundredths, we can see that we have 4 smaller hundredths shaded in. So now we have 2/10 plus our 4/100ths. Okay, so you have your 2/10 and your 4/100ths. Now when we go to add those up, we know that this 2/10 is also 20/100ths plus 4/100ths. So we end up with 24/100ths of a meter. Okay, and then switching over to decimal form would look like that. So now coming over here to do this side with our number bond, we're putting our 24/100ths up on the top and demonstrating that as 2/10 and 4/100ths. Okay. Moving on to C, this time we have 3/10 shaded in. And then looking at our hundredths, if we count each of those hundredths, we can see that we have 8 shaded in. So this time we're adding 3/10 plus 8/100ths. We get 38/100ths of a meter. And then converting that into decimal form looks like that. Okay, so remember that 3 is in the tenths place for your 3/10 over here. The 8 is in the hundredths place, represented over there. So now coming over here to do our number bond. Okay, we have our 3/10, because that's the place that the 3 is in. We have our 8/100ths looking like that. Okay, moving on to question 4. On each meter stick, shade in the amount shown. Then write the equivalent decimal. So our first one here, we have 8/10. Now again, be very careful by looking at the denominator. So 8/10, which means we need to shade in 8 of these sections, because each of those larger squares is represented as 1/10. Okay, so we can take our crayon or our pencil and just lightly shade in 8. Okay. Now moving on to the next one, notice how our denominator has changed. Instead of dealing with tenths, now we're dealing with hundredths. Okay. Now notice how our numerator is a single digit, which means we're less than 1/10. So what we need to do is when we come over here to this first tenth, we need to break this up into 10 smaller sections, because we have less than 1/10. We have a single digit numerator. So what we're going to do, I'm going to draw sections here. Okay, to create our 10 smaller sections, and then using our crayon or our pencil, we can lightly shade in 7 of them. Okay. Now, notice letter C. Now we have a double-digit numerator. So we have 1/10 and then 9/100ths coming in after it. So that means we are going to shade in 1/10. Okay. Then we need to break up our next tenth into hundredths. And then shade in 9 of these. Okay. Now going back up through, remember we need to include the equivalent decimal. So looking at our 8/10ths, okay, we remember that the place directly after the decimal point is your tenths place. So our equivalent decimal looks like that. Now letter B gets a little bit tricky because remember this is 7/100ths. So when we go to write the equivalent decimal, notice how we do not have any full squares shaded in. We have 0/10ths, but we have 7/100ths. Okay, so notice very carefully the difference between letter A and letter B. We have 8/10ths here. We do not have any tenths here, but we have 7/100ths. So please be very careful when you're looking at those decimals and thinking about the place values and what they relate to as the fraction. Now coming into letter C, we can see that 19/100ths. Okay, so we have 1 full tenth shaded in plus 9/100ths after it. Okay. Now moving on to our last question here. Draw a number bond pulling out the tenths from the hundredths as in problem 3. Write the total as the equivalent decimal. Okay, so what that basically means is we're taking our 19/100ths and we're pulling out 1/10 and 9/100ths, just like we did up in problem 3. Okay, so that we can then see that we have 19/100ths of a meter. Okay. Same thing over here, problem B. We have 2/10, 8/100ths. You can see where your 28 comes from. So again, we have 28/100ths. That 2 is in the tenths place, and the 8 is in the hundredths place. Okay, 7/10 and 7/100ths, which then gets us 77/100ths. Okay, so the first 7 is in the tenths place, second 7 is in the hundredths place. All right, and then finally the last one, you can see that we have 9/10 and we have 4/100ths. So it looks like that. Notice that 94 is very close to 100, so our 94/100ths here is almost 1 whole. Okay, all right. Thank you for following along. Please make sure to do the exit ticket next.